This problem involves us calculating the percent yield of a reaction, which is a good indication of how well our experiment went. So, if we have 22.6 grams of aluminum and it reacts completely with oxygen, and we obtain 37.8 grams of aluminum oxide, what is the percent yield for the reaction? So there's a couple of things we need to know here. The first thing is we know already how much material we got, but what we don't know is how much aluminum oxide we should have gotten. That's going to fall entirely, in this case, on the aluminum because we say it completely reacts with oxygen. Since there's no mass of oxygen given, it's assumed that the aluminum is the limiting reagent. Next, we have to check to see if we have a balanced equation. Again, in this case, yes, we do. We see we need 4 aluminums plus 3 oxygens to produce 2 aluminum oxides. So we can start with our aluminum. Again, it's a mass. It's a good starting point when working these problems. Grams is always a great place to start. And we've got 22.6 grams of aluminum. Next, we got to go to moles. Should be a repeating pattern here. We're going to moles. So how many grams of aluminum do you need for a mole? Well, about 27 grams. Again, that comes looking at the periodic table. So 27 grams of aluminum is the same as 1 mole of aluminum. We're interested in figuring out how much aluminum oxide we should produce. So we have to use our mole-to-mole ratio based off the balanced equation, and we can see we need 4 moles of aluminum to produce 2 moles of aluminum oxide. So we'll put 4 moles of aluminum down here. So we can see we've crossed off our grams of aluminum and moles of aluminum. And our 4 moles of aluminum gets us 2 moles of aluminum oxide, Al2O3. Next, we can go through and use the molar mass of aluminum oxide. That is, we know 1 mole of Al2O3 has a mass of about 102 grams. And that's the mass of 2 aluminums and 3 oxygens. Going through and calculating that, I get a theoretical mass of 42.7 grams of Al2O3. That's what I should have gotten. This is my theoretical. And you can see from the problem that when the experiment was done, they only got 37.8 grams. So they obviously lost some aluminum oxide during the course of the reaction, either due to sloppy technique or perhaps not as precise mass measurements as first believed. So let's figure out what the percent yield is. Well, percent yield is simply what you got. In this case, 37.8 grams of aluminum oxide, all over what you should have gotten, or your theoretical, 42.7 grams of aluminum oxide. Since it's a percentage, we're going to multiply it by 100%. And we find when we do so, this reaction was 88.5% efficient, or perhaps that's better to say we had an 88.5% yield.